Okay, so today, we're going to continue our discussion of crystallization. Ano? So last meeting, we have solved the problem whereby you are asked to calculate the yield, ano? The amount of crystal. So today, we're going to calculate the amount of heat needed to remove in a crystallization operation. So saan ba ginagamit yun pag na-calculate nyo na yung amount of heat? So later, meron tayong mga Swenson crystallizer problem. Gagamitin niyo yung amount ng heat to calculate the length of the Swenson-Walker crystallizer. Kung tandaan niyo pa yung Swenson Walker crystallizer, yung kanyang diameter fixed na 0.6 meter. So, ang design parameter lang doon na kinakalculate, yung length lang niya. So, yun. Later makikita niyo yun. Yung application ng calculation ng heat. So, in the meantime, mag-calculate muna tayo ng heat. I'm going to share my PowerPoint. This is the Swenson Walker. Ano? Dito lang ako nag-share. Yan. So this is our first problem today. We're going to calculate the heat balance of a particular crystallization operation. So, ano ba ito ginagawa? Basically, parang ano lang naman, parang yung sa evaporator. Kung tandaan nyo pa yung sa evaporator, yung heat balance niya, di ba, basically, o yung calculation ng heat amount na na ginamit ng evaporator. Basically, kung natatandaan nyo pa, lahat naman ng heat na ginagamit sa evaporator galing sa steam. So that's why yung equation ng heat sa evaporator is S times lambda S. Tandaan nyo pa yon? Tapos, I also described na yung heat na pinrovide ng steam is used to raise the temperature of the feed to the boiling point. Kaya meron kayong term na FCP TB TF. Tapos, yung heat na kailangan para mag-evaporate yung vapor, no? Yung B. So that's B lambda B, no? Tandaan niyo pa 'yon. So FCP times TB minus TF plus B lambda B. That's how you remember the heat sa evaporator. So sa crystallization, yun namang heat na kailangan natin, we need heat para ma-lower yung temperature. 'Di ba pinapalamig natin, bawa cooling siya, no? So halimbawa cooling siya, papalamigin natin yung feed. So that would be FCPF times yung temperature ng liquid, no? Or nung crystal. So that would be the operating temperature of the crystallizer, yung final temperature. So halimbawa TC, you can call it TC or just simply T minus TF, no? Ganun lang yon. Tapos, yung crystal, so merong heat of crystallization. So meron tayong term na plus C lambda C. Yun lang naman yung equation natin. Ano? So Q is equals to FCP delta T. Delta T is temperature, yung final temperature ng liquid, ng solution, no? Minus yung temperature ng feed. Tapos plus C, C is the amount of crystal times lambda C. So I hope na-imagine nyo, mahirap kasi pag minemorize nyo yan, after some time makakalimutan nyo, ang tagal pa ng board exam. Of course, pwede naman kayo mag-review. Pero yun, mag-e-effort pa rin kayong mag-memorize. Pero pag naiintindihan nyo tong equation na to, na-imagine nyo, you need to imagine things. Pag na-imagine nyo kung ano yung nangyayari, hindi nyo makakalimutan yan. Kumbaga, magiging stock knowledge yan. So it's better for you to imagine things. Okay? where are we going to get lambda C? Yung heat of crystallization. So you can get it from the handbook. Ano? So hanapin na lang sa 9th edition. Ito yung sa 8th edition. Ano? So we call this the heat, ang meron dito is heat of solution. So pag sinabing heat of solution, yung solid, nadidissolve. Pag halimbawa nilagay mo yung solid, madidissolve siya. Halimbawa, naglagay ka ng sodium hydroxide na granules, nilagay mo sa water. That's ang tawag doon sa heat na involved niya is heat of the solution. So yung kabaliktaran nun, yung negative nun, ang tawag doon ay heat of crystallization. No? Imagine niyo, halimbawa meron kayong supersaturated yung potassium chloride solution, tapos nag-form ka ng potassium chloride crystals. So ang tawag doon ay heat of crystallization. Tapos ano lang siya, negative sign lang siya ng heat of solution. So you can use this table to get the value of lambda C. So for example, aluminum bromide, aluminum chloride, ano? Tapos you have the heat in kilocalories per mole. So babaliktarin niyo lamang yung sign dito. This is the kalagay naman diyan, ano, heat evolved in kilocalories per gram formula weight on solution in water at 18 degrees Celsius. Okay, so heat of solution to, ano? So i-check nyo, ano, ang nakalagay ata, if I remember this it right, yung nakalagay sa, halimbawa sa sodium chloride, alam niyo naman ang sodium hydroxide. Ang sodium hydroxide, pag tinuon niyo sa tubig, yung solution umiinit, di ba? Tapos if I remember it right, negative yung nakalagay dito. So, ano ba? Ito. So, sodium hydroxide, ano? Positive pala yung nakalagay, ano? So, ang sodium hydroxide ay exothermic. Ibig sabihin, nagre-release siya ng heat pag tinunaw nyo, no? Umiinit. So, since positive yung nakalagay dito, yung heat of crystallization dapat ay negative. Di ba? Ang heat of, I mean, you need some heat para ma-form yung crystal. Na-imagine nyo? Let me... Halimbawa... Ay, sorry. Medyo nakakalito nga lang to. Ano? Pero madali lang naman sa calculation. Sa calculation naman, most of the time, ano? Generally, most of the time, i-add nyo lang yung dalawang term. So, kumbaga pareho sila ng sign. Both of them are negative. Kasi papalamigin nyo, so you need to remove heat. No? Papalamigin nyo muna yung feed. So you need to remove heat. Remember, ang crystallization happens by cooling. So you need to remove heat. Tapos, generally, when you form crystal, you also need to remove heat. So parehas ng sign yung dalawa. So generally, ang heat of crystallization ay negative. Pero sign lang naman yun. Pag dinamit naman natin sa Swenson-Walker, hindi mawawala na yung sign na yun. Siyempre, wala naman kayong negative length. Ano? Hindi naman imaginary yung Swenson-Walker nyo. So, magiging positive din. Eventually, magiging positive din yung amount ng heat. Ang importante doon is generally, ina-add yung dalawang term. Yun yung dapat yung tandaan. No? ang sodium hydroxide naman kasi is not produced through crystallization. So, naturally, pag tinanggal niyo yung tubig niyan, you don't need a crystallizer. Magsusolidify na agad yung sodium hydroxide. Ano? Flakes kasi yan eh. So, hindi naman ginagamitan ng crystallizer ang sodium hydroxide. Yung mga fine chems, halimbawa, yung mga potassium chloride, calcium chloride, yon kailangan talaga ng crystallizer yon. So, usually ang mga example dito, yung lambda C ay negative. Or actually, hindi mo importante. Ang importante is the same sign siya do sa first term. Okay? Kasi ang kailangan nyo yung absolute value. Pag mali yung sign na ginamit nyo doon sa lambda C, magkakamali yung absolute value ng answer nyo ng Q. So, anyway, trace na rin natin to. Ano? So, kita nyo dito yung sodium hydroxide. On na ba yung pen ko? Yung sodium hydroxide, ang kanyang heat of solution ay positive. No? So, imagine niyo pag ginamit natin yung convention, di ba, pag heat palabas, negative. So dapat ang sign dito negative. Kaya lang nakalagay sa table positive kasi nga ito yung heat, parang ano to heat release. Yung description ni Perry. Bakit positive siya? So this is the heat evolved, no? Heat evolved. So yung lumabas na heat evolved. Heat evolved kasi kaya positive siya. So this does not follow the does not follow our convention, no? So heat evolved ito. So hindi niya pinapollow yung usual convention ng thermodynamics, no? So positive yung lumalabas pag dinisolve mo siya. So pag ginawa mo siyang crystal, ibig sabihin, babaliktarin mo yung sign nito. So magiging negative. Nagre-release siya ng heat. Kalito ako nalilito na. Nagre-release siya ng heat. So pag nag-crystallize siya, mag-a-absorb siya ng heat. Ito pala exception to. Ang sodium hydroxide, yung first term niya, yung FCP delta T, at saka yung second term niya, hindi magkaparehas ng sign. No? Tama? Kasi pag nag-form siya ng crystal, kailangan niya ng heat. So, positive siya. Positive yung lambda C niya. Okay, opposite siya. Ang importante doon, opposite siya ng sign doon sa first term. Doon sa FCP delta T. Ganun yung gamit nito. Pero sabi ko nga sa inyo, generalization, most of the time, i-add yung first term at saka second term. Tapos, kung we're going to follow the convention, dapat negative yung Q ng crystallization generally. Okay? Pero kung halimbawa sa choices, puro positive, syempre, ba't ka naman maghahanap ng negative? Puro positive yan. You need to adjust, ha? You need to adjust. Hindi pwede dito, sa Kemeng, hindi pwede yung mga absolute thinking people. Hindi pwede yung mga ganun dito. Dapat marunong kayong mag-adjust, mabilis kayong mag-adjust. Kasi talagang binabali-baliktad, matatalino kasi ang mga Kemeng. So hindi pwede dito yung, ay gusto ko ganito lang yung rule, ay gusto ko ganito lang absolute. Hindi pwede yung ganun dito. Dapat marunong kayong mag-adjust. Mabilis kayong mag-adjust. Kahit na pag nagtrabaho kayo, makikita nyo yung field. Mga smart people ang mga KMN. Pag babagal-bagal kayo, pagbubulungan talaga kayo. Lalo na if you're in a KMN company, pag medyo babagal-bagal kayo, pagbubulong-bulungan talaga kayo. Hindi nyo lang alam. Pero malalaman nyo rin. So, yun. You really need to develop. Okay, so let's take a look at the old word question. Yun na naman The heat of solution of saltpeter in kilocalories per mole is blank. So you really need to memorize, you really need to remember kung ano yung saltpeter. Otherwise, hindi mo siya mahanap sa table. Kahit na meron ng mark yan sa handbook nyo, pag hindi nyo alam kung anong saltpeter, hindi nyo pa rin mahanap. Kasi ang pangalan ng mga compound ay chemical name. Wala naman dong saltpeter. So anong saltpeter? Potassium. It's potassium. Yep, it's potassium nitrate. Yep, very good, Paolo. It's potassium nitrate. So yun yung nakalagay sa So it's negative 8.633. Ganun, Yun, letter C, Letter C. Negative 8 point. Do you have any question? Dali lang naman, hanapin nyo lang sa table. So, sana meron sa 9th edition. Actually, nawawala lang naman yung mga hindi na ginagamit. I think hanggang ngayon naman ginagamit pa rin naman to. Yep. Halimbawa to, another old word question. The heat of solution of hydroxybenzene in calories per mole is blank. So how do you find this? Halimbawa, this is another table. You can find this on page 206, chapter 2. Okay, basta mga properties, chapter 2 yan. Table 183. So anong sagot? Hydroxybenzene. Kita nyo na? No, walang hydroxybenzene. Paano na yan? Anong sagot? Sino nakakita na? Anyone? Walang hydroxybenzene. No? Anong sagot? Imagine niyo hydroxy. What is hydroxy? Tapos benzene. What is benzene? Tapos na kayo organic chem, di ba? Favorite ko yung organic chem. Pero, mataas naman ang grade ko dyan. Ano? Pero, kumuha ako ng advanced organic chem. Wala ako sinabi sa mga chem major. Magagaling yung mga chem major. Kasi they have 10 units of organic chem. Samantalang kami, we only have kalahati lang. No. Mas detail talaga yung organic chem nila. Kita nyo na? So what is hydroxybenzene? Yan, may nakakita na. Negative 2605. Wala pa pala. Hydroxybenzene, may nakakita na? Wala. Hydroxy, what is hydroxy? Yeah, sige, hanapin niyo sagot. Sino yun? Gio? Very good, Gio. Anong sagot? Nakikita niyo ba yung table? Nababasa niyo? Yeah, very good. Negative 2605. No, ang hydroxy, di ba, OH, tapos ang benzene, of course, yung ring, piatos, o di phenol yun. So, pag phenol, ito yon, negative 2605. Ha? Kailangan talaga mabilis mag-process, no? Yung nag-board exam. I don't think magbababa. Hanggat sina Sir Mihares yan, ganyan yung level ng KMM board. Ito yun, ano? Malakas pa si Sir Mihares. Matagal pa yung mapalitan. So, solid pa rin ang second day. Yung second day, yun yung iniiyakan. Maraming mga nag-i-exam, hindi na pumupunta ng third day. I don't know. Kaya nga sabi ko sa inyo, totoo rin naman yung sinasabi nila. Emotion ang board exam. Kayong iiyak, dapat lang. Dapat firm lang. Baksak kung baksak, parang ganda. Sugod lang ng sugod. Diyos ko, ang daming umiiyak ng second day, pumapasa rin naman sa board exam. Ang first day, ibang istorya naman yung iyak sa first day. So, yung second day, mahirap talaga, pero may mga sagot. Third day, okay naman ang third day, wala nang problema. Ang third day, yung general engineering, hindi nyo na kailangan ng handbook. Mag-solve lang kayo sa 1001 solve math problems. Okay na. Okay naman si Ma'am Sid. The last MTV, you know what MTV is? Meet the boards. Wala na si Ma'am Bulaong, hindi matan si Ma'am Bulaong, may sakit daw. So, yun, baka magkaroon ng susunod na board exam, baka pag kayo hindi na si Ma'am Bulaong. Hindi mahina na siya. Okay, any question regarding finding the heat of crystallization? Pero usually given naman yan sa problem. Yun nga lang, you really need to determine the sign. Kaya lang sabi ko naman sa inyo, usually ang sign niyan, parehas yan ng sign ng first term. No? Yung FCP delta T at saka yung C lambda C, parehas ng sign. So basically, i-add nyo lamang yung dalawa to calculate Q. No? Let's try to solve problem 12.11-2. Ito yung, di ba, the last one we solved is 12.11-1. So Gene-Copless pa rin to, So we have a feed solution of 2,268 kg at 327.6 Kelvin containing 48.2 kg magnesium sulfate per 100 kg total water. This is cooled down to 293.2 Kelvin where magnesium sulfate heptahydrate, what is this? What is magnesium sulfate heptahydrate? Nilalagay sa bathtub. Okay, check niyo yung pinamemorize ko sa inyo, ha? Yan. Salt yan. So what kind of salt? Crystals are removed. The solubility of the salt is 35.5 kilogram magnesium sulfate per 100 kilogram total water. The average heat capacity of the feed solution can be assumed as 2.93 kilojoules per kilogram Kelvin. Ito yung CPF, no? Specific heat ng feed. The heat of solution at 291.2 Kelvin is negative 13.31 times 10 to the 3 kilojoules per kilogram mole magnesium sulfate heptahydrate. Yan na. No? So, may negative yung sign dyan, tapos heat of solution siya. So, ibig sabihin, pag kukunin niyo yung heat of crystallization, magiging positive yan. Diba? Babalik na rin niyo yung sign. So, paano yung relationship niya sa ano, sa first term, sa FCP delta T? Yung FCP delta T palagi negative yan kasi cooling ang crystallization eh. 'Di ba? Final temperature is final minus initial. So, you can use the table to check yung kung ano talaga yung sign ng lambda C, no? Ng heat of crystallization. Sabi ko naman sa inyo, palaging ano yan, palaging negative ang heat of crystallization, ano? So ito negative din to. Although sa problem ni Jacob is nakita nyo negative. Kasi this is heat evolved. This is heat evolved. Yung heat of solution, heat evolved yan. So babalik ta rin nyo, tapos babalik ta rin nyo ulit. So magiging negative siya. Ganun yung kwento nyo. Ano? Nalilito na ba kayo? Dalawang baliktad? Nakakahilo na ba? Anyway, basta i-add nyo lang yung first term at saka second term. Yun yung pinakamadali dyan. So calculate the yield of crystals and make a heat balance to determine the total heat absorbed Q, assuming that no water is vaporized. So let me share a whiteboard kasi medyo mahaba yung solution. Okay, so first let me write the given. We have 2,268. No, this is F. So F equals to 2,268 kilogram. So ito yung papasok doon sa crystallizer natin. Bawa ito yung crystallizer natin. Wala naman nag-evaporate, no? So we only have the liquid and the crystal. So crystal is given to be magnesium sulfate heptahydrate. 7H2O. Kailangan niyo yung molar weight nito. Ano? Tapos ang solubility niya sa solution ay 35.5. So this is kilogram magnesium sulfate per 100 kilogram of water. Tapos dun sa feed, ang kanyang concentration ay 48.2 kilogram. I need to solve this in 10 minutes. Kilogram magnesium sulfate per 100 kilogram of water. Okay, so first you need to find C kasi required siya, ano? So how do you find C? So basically ganun ang step natin, mag-overall mass balance tayo. It's the formula for overall mass balance. F is equals to L plus C. Wala naman kasi tayong B, ano? So just substitute 2,268 kilogram tapos L plus C. Tapos magma-magnesium sulfate balance tayo. Magnesium sulfate is 2,268. So this is kilogram solution. Naintindihan niyo na last meeting kung bakit kailangan i-multiply nyo dito ay 48.2. So this is kilogram magnesium sulfate. MgSO4. Tapos divided by 148.2. Of course, yung 148.2 water plus magnesium sulfate, and that is also kilogram solution. So para mag-cancel out ito, ano? Mag-cancel out yun. So pag nag-cancel out yun, kilogram magnesium sulfate na lang to, ano? So is equal to, so yung L, ang multiply nyo dito is 35.5. Naintindihan nyo na, di ba? Nagawa nyo ng exercise, 135.5. Tapos plus yung C. Yung C naman yung molar mass. So, So ito yung molar weight ng magnesium sulfate. Tawag dito, gravimetric factor, ano? Tapos yung sa ilalim niya, yung molar weight ng magnesium sulfate 7H2O, ano? So pag chinek nyo, pag kinalculate nyo, that would be 120.48. This is 120.48. At saka this one is 246.48. Okay, so just try to calculate C. C yung kailangan natin using your calculator. 7 minutes. So, ayan. So, 1, 1, tapos 2268. Tapos second equation, 35.5 divided by 135.5. Tapos second equation, 120.48 divided by, marunong naman kayo mag-calculate ng molar mass, ano? Divided by 246.48. Tapos 2268 times 48.2 divided by 148.2. So you're supposed to get, ilan nakuha nyo na C? Supposed to get Yep, very good. 632. Very good, Emmanuel. Very good, Angela. Si Gio, very good. Paolo, very good. Okay, 632. Ano? C is equal to 600. Tapos, yun na. To calculate Q, so ang formula lang natin is FCP. Tapos, yung temperature, yung final temperature, minus yung temperature ng feed, delta T, ano? Plus yung C, tapos times lambda C. So, gusto nyo, gawin nating positive. So, MF natin ay 2,268 kilogram. Ang C ay 2.93, ano? 2.93. This is kilojoules per kilogram Kelvin. Okay, cancel to, di ba? Tapos multiply natin ng temperature na given. So 327.6 minus 293.2. Yun yung follow. Medyo binaliktad ko na para positive na siya. No? Para pag in-add natin yung isang term, i-add yung dalawa eh. So yung C natin is 632 kilogram. Tapos yung lambda C, yung given na 13.31 times 10 to the 3 times 10 to the 3. This is kilojoules per mole. Per kilomole. Per kilomole. So i-divide nyo to nung 240 per kilomole of of magnesium sulfate heptahydrate, ano? So i-divide nyo to nung nung 246.48. Can you see the dimensional analysis? Ito is kilogram per kilomole. So magka-cancel yung kilomole, kilojoules per kilogram. So magka-cancel yan, kilojoules na rin to. Ito naman, nag-cancel yung Kelvin. So kilojoules na rin. So pareho silang kilojoules. Okay lang, do you have any question regarding the dimensional analysis? So calculate nyo na lang yung Q. So 2268 times 2.93 times 327.6 minus 293.2 parenthesis. Hindi ako naka-mode 1. Okay? So 2268 times 2.93 times parenthesis 327.6 minus 293.3 plus 632 times 13.31 exponent 3 divided by 246.48. Okay? So, ilang nakukuha nyo? Something like, ilan? In millions. Ilang kilojoules? We're supposed to get Q is equals to Halimbawa, 3 significant figure. Kaya lumalabas sa inyo. Wala pa. 13.31 times 10 to the 3 divided by 2 for 6.48. 63, yung second term, ano? 632 times 13.31 times 10 to the 3 divided by 2 for 6.48. That's the molar mass of magnesium sulfate heptahydrate. So you're supposed to get something like 2.63 times 10 to the 6 million. No, kilojoules. Yeah, meron bang nakasagot? Tama ba to? Tama yan. 267724. 2.63 times 10 to the 6. Very good. Gio, very good. John Paolo Masin, very good. Now, do you have any question regarding the calculation of Q? So yung complication lang talaga dito, yung yung sign ng lambda C. Madali lang naman yung formula. I hope you understand how I remember it. Tapos generally i-add nyo lang yung first term at saka second term. Kung gusto niyo makasigurado, i-check niyo sa handbook kung talagang exothermic yung or endothermic pala yung crystallization. You can check sa handbook. Most of the time endothermic yan. So what I want you to do, if you don't have any question, is to solve this problem. Okay, screenshot kasi mapuputol na yung natin, 1 minute and 35 na lang. You can check naman the answer sa PowerPoint. Download nyo lang yung PowerPoint, tama naman yun. So you need to solve this problem. Paki-screenshot. Pero actually, di-display ko rin naman sa sa whiteboard. We only have 1 minute and 21 sa Zoom. So mawawala yung Zoom natin. Tapos I'm going to share probably another link of Zoom. Reconnect na lang kayo. So, yun. You also need to calculate Q in this problem. So paki-screenshot na lang para ma-solve nyo agad. So, mawawala na yung Zoom natin. Makakat na siya. I'm going to provide another link. Tapos ito, lalagay ko sa bin. You can find this sa bin. Sa BBL. Okay, see you in the other link. Screenshot para ma-solve nyo. Okay, see you in the other link.